For over a century, British locomotive builders ruled the rails of the Indian subcontinent. Names like Vulcan Foundry, North British, and Bayer Peacock weren't just suppliers. They were symbols of imperial engineering superiority. Every major locomotive that powered India's colonial railways bore the stamp "Made in Britain." But in 1947, as the British Raj crumbled, something remarkable happened in a workshop in Chittaranjan, West Bengal. Indian engineers, many trained under the very British system that had dismissed their capabilities, designed and built a locomotive that would outperform, outlast, and ultimately humiliate every comparable British design of its era. The WP class wasn't just a machine. It was a declaration of independence written in steel, steam, and stunning technical achievement. The story begins not with triumph, but with desperation. When India gained independence in August 1947, the new nation inherited a railway network of over 40,000 miles, one of the largest in the world. But it also inherited a crippling dependence. Nearly every locomotive, every boilerplate, every precision casting came from British factories. The partition had severed vital supply lines. Workshops in what became Pakistan were suddenly foreign territory, and Britain, exhausted by war and focused on rebuilding Europe, had little interest in prioritizing locomotive orders for its former colony. India's first railway minister, John Mathai, faced a stark reality. The country needed hundreds of new locomotives to drive industrial development, move food during famines, and transport raw materials for factories. But waiting for British builders meant years of delays, in inflated costs and continued subservience to foreign engineering decisions. The colonial-era locomotives still in service, aging X-class mixed-traffic engines, and worn-out XC-class passenger haulers, were designed for British priorities, not Indian needs. They struggled in the summer heat of the Gangetic Plains. They choked on dust during monsoons. Their fireboxes, sized for Welsh coal, wasted the abundant but lower-quality Indian coal that was actually available. In 1947, the decision was made. India would build its own locomotives, not modified British designs, not license-built copies, original machines engineered specifically for Indian conditions by Indian engineers. The announcement was met with skepticism bordering on contempt in British engineering circles. In one locomotive superintendent from the old Great Indian Peninsula Railway reportedly laughed at the proposal, saying Indians lacked the precision mindset required for locomotive design. After all, no Asian nation had successfully built modern express passenger locomotives without direct European supervision. But the team assembling in Chittaranjan wasn't starting from scratch. Many had spent decades maintaining, rebuilding, and modifying British locomotives. They knew intimately where British designs failed on Indian rails. They understood that the standard British 462 Pacific designs, optimized for the temperate climate and high-quality coal of Britain, were fundamentally mismatched to subcontinental realities. The design team, led by Chief Mechanical Engineer B. Subba Rao, made choices that would have been controversial in any British drawing office. They started with a wider firebox, far wider than standard British practice, to burn the low-grade Indian coal efficiently. The great area measured 51.5 square feet, enormous compared to the 40-square-foot grates typical on British Pacifics. This wasn't just accommodation, it was optimization. Indian coal has lower calorific value, and higher ash content. A larger grate meant more complete combustion and less clinker formation that would choke the fire. They designed the boiler for sustained high-pressure operation in extreme heat. British locomotives typically ran at 200 to 225 pounds per square inch. The WP would operate at 210 pounds per square inch, but with a boiler designed to maintain that pressure in 110-degree Fahrenheit ambient temperatures. The evaporative heating surface totaled 2,257 square feet, with a superheater adding another 725 square feet. These weren't arbitrary numbers. They were calculated for the specific thermal efficiency curves of Indian coal. The valve gear was perhaps the most revealing choice. British builders favored Walschaerts valve gear for its simplicity and ease of maintenance. The Indians chose it too, but with modifications. The valve events were optimized for the long, steady runs across the Indo-Gangetic Plain, not the stop-start suburban work common in Britain. The result was a locomotive that could sustain 60 miles per hour for hours without losing steam pressure, a critical capability for the mammoth distances between Indian cities. But the most audacious decision was aesthetic and psychological. The WP would not look like a British locomotive. While British Pacifics of the era featured streamlined casings and elegant curves, design flourishes that added weight and maintenance complexity, the WP was nakedly functional. Its lines were bold and geometric. The boiler sat high on the running plates. The cylinders jutted forward without decorative fairings. It looked like a machine built to work, not to impress British railway directors at a platform ceremony. Construction began in 1947 at the Chittaranjan Locomotive Works, a facility built during the war years to reduce dependence on foreign supplies. The first WP, numbered WP7001, emerged from the erecting shop in November 1947. It rolled onto the test track bearing a simple brass plate. Made in India. No ceremony, no British dignitaries. Just a machine, ready to prove itself. Now, the early test runs were brutal. British engineers, still holding advisory roles in Indian railways, predicted catastrophic failures. The wide firebox would crack under thermal stress. The boiler wouldn't maintain pressure with inferior coal. The axle loadings, 20 tons per axle, heavy by British standards, would destroy track. Every prediction was documented, perhaps to create an evidence trail for the inevitable failure. Instead, WP7001 exceeded every performance target. On the test track between Chittaranjan and Sitarampur, it pulled a 600-ton train, 12 coaches, fully loaded, at sustained speeds above 55 miles per hour. Fuel consumption measured at 92 pounds of coal per mile, significantly better than the 110 pounds typical for British-built XB-class locomotives doing similar work. The firebox didn't crack. The boiler held pressure so consistently that crews reported they could judge time by the steam gauge. And far from destroying track, the WP's weight distribution actually produced less rail wear than lighter British locomotives with less sophisticated suspension. Word spread quickly through India's railway workshops. Crews who'd spent careers nursing temperamental British engines suddenly had a machine that just worked. Fitters discovered the WP needed fewer repairs. The standardized components, every WP built to identical specifications, meant a broken part on one could be swapped from another in minutes. British locomotives, each slightly different due to batch variations and individual builder preferences, required custom fitting and adjustment. By 1950, Chittaranjan was producing WPs at a rate British builders had deemed impossible for an Asian facility, nearly one per week. The design proved so sound that it remained essentially unchanged for 2 decades. Total production reached 755 locomotives, making the WP class the most numerous class of passenger steam locomotive ever built in Asia. But numbers tell only part of the story. The real humiliation came in direct comparison. In 1953, Indian Railways arranged what it officially called a compatibility study, but what everyone understood as a showdown. A British-built XB-class Pacific, built by Vulcan Foundry in 1945 and representing the pinnacle of late colonial locomotive design, would run identical schedules against a WP on the Grand Trunk route between Delhi and Kanpur, a 304-mile route that crossed plains, climbed grades, and challenged locomotives with heat, dust, and long distances. The XB went first. Built for British coal, its narrow firebox struggled with the Indian fuel. Crews had to work constantly to break up clinker and maintain steam. Fuel consumption hit 120 pounds per mile. Water consumption exceeded boiler capacity on the grades near Tundla, forcing an unscheduled stop to take on water. The XB completed the run, but arrived 18 minutes late and with a fireman near collapse from the heat and effort of firing. The WP made the same run 2 days later. It departed Delhi on time, climbed the grades without losing pressure, and arrived in Kanpur 4 minutes early, despite following the exact same schedule. Fuel consumption, 89 pounds per mile, no unscheduled stops. The fireman reported the run as routine. The data was quietly circulated among railway officials. British builders, hoping to secure post-war contracts, found their proposals suddenly unwelcome. Why import locomotives at premium prices when indigenous designs outperformed them? The Vulcan Foundry, which had built locomotives for India since 1852, received its last Indian order in 1955. North British Locomotive Company, once the largest supplier to Indian Railways, stopped bidding on Indian contracts entirely by 1958. The WP didn't just replace British locomotives, it redefined what Indian engineering could achieve. Chittaranjan became a proving ground for a generation of engineers who would go on to design diesel and electric locomotives, build India's nuclear program, and launch satellites. The confidence born in those workshops, the knowledge that Indian engineers could match and exceed foreign expertise, rippled through Indian industry. Yet outside India, the WP remained virtually unknown. British railway journals barely mentioned it. American locomotive enthusiasts, fixated on Union Pacific big boys and Pennsylvania Railroad T1s, never knew that the most successful Pacific design of the post-war era was running through Rajasthan and Uttar Pradesh. When steam ended in Britain in 1968, railway historians compiled exhaustive lists of great locomotives. The WP appeared in none of them. There's a deeper irony here. The British had spent 2 centuries insisting their engineering was superior precisely because it was British, that Indian conditions required British solutions delivered by British experts. The WP demolished that myth not by being exotic or revolutionary, but by being better engineered. It succeeded because Indian engineers understood Indian railways in ways British builders, no matter how skilled, never could. Today, long after steam disappeared from most of the world's railways, a handful of WPs still survive. WP 7200 operates tourist trains in Rajasthan. Others sit in museums, polished monuments to a vanished era. But their real legacy isn't the machines themselves. It's the proof, stamped in steel and validated by millions of miles of reliable service, that engineering excellence has no nationality, that the colonized could out-engineer their colonizers, that the assumptions of imperial superiority were always illusions. The British built India's railways, but Indians built the locomotives that proved those railways didn't need Britain anymore. In the end, that might be the most profound engineering achievement of all, not just designing a superior machine, but dismantling the myth that such superiority was ever exclusively Western. The WP didn't just haul trains, it hauled India into its industrial future, one precisely calculated, carefully optimized, triumphantly indigenous mile at a time.